Welcome back to Math 103. This is video number 32 on growth and finance. Suppose that you need to borrow $30,000 right now, and the annual interest rate is 12% compounded annually. If you make annual payments beginning 1 year from now and ending 10 years from now, how much should each of your annual payments be? And how much interest in total will you end up paying over the course of the next 10 years? To answer this question about how much your annual payments should be, let's first note that if we wrote out this expression of a big sum, everything looks the same as for 15 years, except that there are only 1, 2, 3, etc. up to the 10th term. Furthermore, in the formula, all the inputs are the same except for the number of terms, which is 10 instead of 15. We go and compute, see what the formula tells us. We end up at this stage with a somewhat smaller number than we had in the 15-year example. So 30,000 divided by something a little bit smaller than last time gives us a larger payment amount than we had last time. We conclude that your annual payments will have to be $5,309.52 per year, beginning 1 year from now and continuing until the last payment 10 years from now. By contrast, in the 15-year version of the loan, you would have to make approximately $4,400 payments every year. That means that if you decide that you're going to pay off this loan in only 10 years, you're committing to coming up with an extra $900 a year, approximately, when you make your payment. That's part of the bad news. There's good news, though, as we'll see. How much interest will you have to pay? Let's first compute the total amount that you would have to pay back if you paid off the loan in only 10 years. At $5,309.52 per year, for 10 years, you'd pay back a total of $53,095.20. That's over the course of 10 years. So you have to pay back this total amount, $53,000 and change, in exchange for the opportunity to borrow $30,000 right now. Now that's not nearly as bad as the situation for the 15-year loan. This is really much less painful. For the 10-year loan, you'd end up paying the total amount, $53,000 and change, minus the $30,000 that you borrowed. That difference is $23,095.20. So sure, you have to pay back the original $30,000, but the amount additional to that you have to pay back, the amount of profit the bank is making off this loan, is $23,000 something. Is that good or bad? Well, it's a whole lot better than the $36,000 something that you would have to pay in interest in the 15-year version of the loan. So paying off the loan in only 10 years saves you a lot of money in interest. What conclusions can we draw from this? The longer-term loan allows you to make smaller payments each year. The 15-year loan had smaller payments each year than the 10-year loan. On the other hand, the shorter-term loan, the 10-year loan, costs you much less in interest over the life of the loan. So if you can afford the larger payments of the 10-year loan, you're probably better off taking out that 10-year loan and being done after 10 years than taking out the 15-year loan. Our examples so far have all involved annual payments and annual compounding. We remarked that it's very common in real-life situations for these loans to be set up with monthly payments. So let's investigate. What if the payments had been made monthly rather than annually in our example? What if you wanted to know the size of each monthly payment? So more precisely, suppose you need to borrow $30,000 right now, and the annual interest rate is 12%, as before, but it's compounded monthly now. So if you make monthly payments beginning 1 month from now, and ending 15 years from now, how much should each of your monthly payments be? We do have to be a little careful about the values of I and N, so the interest rate per month now, and the number of payments, but otherwise the thought process really is the same. First, let's understand the value of I. This is 12% annual interest, so 1 plus I needs to be 1 plus 0.12 over 12, because we have to turn an annual interest rate into a monthly interest rate. That is a familiar thing from earlier in this chapter. That's where this 1.01 is coming from. That is our 1 plus I. What about n, the number of payments? So let's first understand the first payment we make is paying back bank number 1, to which we were in debt for 1 month. Because the story was, we borrow money on a certain day, today, and we make our first payment 1 month from now. So the first repayment pays back a debt of 1 month, 1 month's worth of debt. How many payments are there in year number 1? So from now until a month from now, that's 1 payment. From now until a year from now is 12 payments. And from now until 15 years from now is 12 times 15 is 180 payments. So notice I'm taking out money today. I'm not also making a payment today. That would make it 181 payments. No, I'm taking out money today, and I start making payments in 1 month. I make 12 payments a year for 15 years. That brings my last payment to be the 180th payment. All that remains now is to carry out the computation using this present value formula. Plugging in 30,000 for PV, 0.01 for I, and 180 for N, the number of payments, we work out the computation. It turns out a rather large number now appears here next to PMT at this second-to-last stage, which means that when we compute 30,000 divided by this number to solve for PMT, it's actually quite small relative to our previous computations. Each payment is only just over $360, so $360.05. There are many more of these payments before we're finished, but each payment is relatively small. Before going on to the next video, answer the following questions. Which version of the 15-year loan requires you to pay more in interest? The one with annual payments of $4,404.73 each, and 12% interest compounded annually, or the one with monthly payments of $360.05 each, with 12% annual interest compounded monthly. After you've figured out the answer to this question, and decided which version of the 15-year loan is worse, that is to say, makes you pay more in interest, having figured out which one is worse, why does the answer make sense conceptually?